All right, so the first thing we got to do is we're going to talk about solving systems of equations by graphing. So the first thing, a system of equations, we got to fill in that definition up there. So a system of linear equations, that is going to be two equations containing two variables. All right. And then the solution that we're looking for is we're going to graph each equation. We're going to graph each line. They're linear equations. And we're going to look for the place where the two graphs hit each other. We're looking for the point of intersection. So I guess we'll just fill in. We're looking for where the two equations hit. So we're really looking for the point or the ordered pair x comma y where they hit each other. So I'm going to write in ordered pair. All right, so let's look at example one. So example one, they've already given you the solution. So the solution is right here. Now what that means is x equals 5, y equals 2. That makes both of these equations true at the same time. Okay? So we're supposed to check and make sure that if we plug in the 5 for the x and the 2 for the y, that both equations are true. So let's do that. So we're going to plug in 5 for the x in the first equation. That would look like 2/5 times 5 minus the y value, which is 2. And we want to see if that's equal to 0. Well, I think you guys can see this 5 on the top and the 5 on the bottom. They would cancel out. So you would just get 2 minus 2 equals 0. So that's true. So this point right here, the point 5 comma 2, that definitely makes the top equation true. Then you just want to plug that in, x equals 5 and y equals 2 into the bottom equation and see if that one's also true at the same time. So let's do that. So we're going to do 3 times the x is 5, and then minus the y is 2, and that should equal 13. And you can see that that works, right? So right here you have 3 times 5, that's 15. 15 take away 2, that's 13. So that one's also true. So that's what we're going to do now. We're going to graph each line, and then we're going to look for the point where they cross. And just like this point here, this ordered pair, that point is going to make both equations true at the same time. I'm not going to do number 2. You would just do the same thing, okay? You plug in -2 for x and 2 for y. And if it makes both of these equations true, then it's a solution. If it doesn't make both equations true, then it's not. All right, so now to graph the lines, let's fill in this blank. It says, what's your favorite way to graph a line? So it's kind of up to you guys which method you want to use. You could use slope-intercept. Which is your y equals mx plus b. Or you could use point slope. Which is the equation looks like y minus y1 equals the slope times the quantity x minus x1. Or if the equation was given in standard form, you could just find the x-intercept and the y-intercept. So you could use x and y intercepts. And if you remember that, that's where I made that little table. And I plugged in 0 for x and then 0 for y. So it's going to kind of be up to you, whichever way is easiest to graph. So let's look at example 3. Try to fit this. All right, there you go. Okay, so we're going to graph both of these lines. So the first line, the top equation is y equals x. Well, that would be the same thing as, that would be y equals 1 over 1x plus 0. So on that one, your y-intercept, that's 0. And then your slope right here, that is 1 over 1. So let's plot the y-intercept. So the y-intercept is at 0, so that's where the graph hits the y-axis right here, right at the origin. And then the slope is up 1 over 1. And then up 1 over 1 again. You can keep doing that. But it's these points right here. Now I'm going to try to graph this on my iPad with a ruler, so it's a little weird, so hold on here a second. So that is going to look something like that. All right, now we got to graph the second line. The second line, the y-intercept is -3. So let's plot that. Maybe I'll do this one in red. So the y-intercept is at -3, so put a dot there. And then my slope for this one is -2 over 1. So remember, that top number tells you how far you go up or down. So since it's negative, you go down 2. And then you go to the right 1. From your y-intercept. So you're going to go down 2, right 1. And then we can keep doing that to be a little more accurate with the graph. So we're going to go down 2, right 1. And I think you can see kind of where these are going to hit. If I was going down to right 1, I could also go up to left 1. Looks like they're going to hit right there. But let me try to graph this one. Something like that. All right. So again, what we're trying to find is we're trying to find the point where the two lines hit each other. So that is the point right here, that blue point. Then you just got to write down the ordered pair for that point and you're done. So that one, that is the point. Let's see, it's 1 left, 1 down. So 1 left for x and 1 down for y. You can write the answer like that as an ordered pair. Or you can write x equals -1 and y equals -1. Either way. So that's your solution for number 3. And then if you plug that x and y in, so if you plug in this x and this y into the two equations up here at the top, it should make both of those equations true at the same time. That's what you're trying to do. Let's do number 4. So there's 4. The top equation is in slope-intercept form already. So to be in slope-intercept form, you want to solve for 1y. So you want 1y all by itself on the one side of the equation, which you already have. So that means that your y-intercept on this one is, again, -3. So we could plot that point on the y-axis at -3. And then your slope on this one is the number that's out in front of x. That's the coefficient of x. So that is 1/3. So the top number tells you if you go up or down. Since it's positive, you go up 1. And then the bottom number tells you how far you go to the right. So you go to the right 3 from your y-intercept. So you go up 1, right 3. And then you go up 1, right 3. I'll do it again, up 1, right 3. So let me graph that top line, or that first line. Hold on one second. There you go. All right, then we got to do the bottom line. Well, on that one right there, it's not in slope-intercept form. You could solve it for y. So you could subtract 2x on both sides. The 2x's on the left would cancel out, and that would leave you with 1y equals, but you want to write the x term first. So you would write -2x, and then that's a +4 right there. So you'd write +4. So you could graph that now if you wanted to, just using that. Your y-intercept is 4, and your slope is -2/1, so you go down 2/1. But actually on this one, I'm going to graph it a different way. So since that's in standard form, so that equation 2x plus y equals 4, that's in the form ax plus by equals c. So since it's in that form, I'm actually going to use the intercepts to graph that one. So I'm just going to make that little table. And I'm going to plug in 0 for x and 0 for y. Well, if I plug in the 0 for the x right here, well, 2 times 0 is 0. So we would just cover that up. But I guess on here, what I'll do is I'll just kind of do this. Well, then you get y equals 4. So that's your y-intercept. Then if you plug in the 0 for y, right here, well, then we would just cover that up. And then we would just solve that equation, 2x equals 4. So just divide both sides by 2, and you would get x equals 2. So I'm going to use those 2 points to graph my line. I'll do this one in red. So we got the point 0, 4. That's my y-intercept. That's right here. And then we have the point 2, 0, which is right here. Well, if you kind of look at that, you can see my slope is what? To go from the point on the left to the point on the right. I'll call that the point on the left, and I'll call this the point on the right. So to do that, I would go down 1, 2, 3, 4, and right 2. Well, going down 4 and right 2, that's the same thing as going down 2 and right 1. So if I go down 2, right 1, and I can go down 2, right 1, I can see then where the points are going to, or where the 2 lines are going to hit each other. I could also go up 2 and left 1. So let me graph that second line for you guys. Again, this section, it's pretty tough to get an accurate answer unless you're using graph paper and a ruler. So that second line looks something like that. All right, and I think you can see where they hit. Those two lines hit each other right here at that blue dot. So that's our solution, the coordinates or the ordered pair for that blue point. So let's see, that looks like that is what? That's right 3, down 2. So the solution for number 4 should be right 3, down 2. Or again, if you want to write it this way, you can write x equals 3, y equals negative 2. Either way. All right, well, the next thing on the note packet, it's about using a graphing calculator. Well, obviously, most of you guys do not have one. You could get one off the internet, but we're not going to do that. So I'm not going to do the graphing calculator part unless we were in class, then we would use the calculators that we have here. So let's move down to the story problem. So to pick up the story problem here, okay, so this story problem says Ryan and Jenny are reading the same book. Ryan's already got 14 pages done, and he reads 2 pages every night. So for Ryan, his equation would look something like this. It would be y equals what do we got? 2 pages every night, and he already has 14 pages done. Okay, so in this equation, x represents the number of nights. So this is the number of nights. So let's see, number of nights. And then the y would be the total pages that have been read. You can see then, for example, if x is 1, well, 2 times 1 is 2, plus 14 would be 16. So after 1 night, he's read 16 pages. After 2 nights, you would put 2 in for x. 2 times 2 would be 4. 4 plus 14, that would be 18 pages read after 2 nights. So then we're going to write the same kind of equation for Jenny. So for Jenny, it says that she has started on page 6, or she already has 6 pages done, and then she reads 3 pages every night. So her equation. What's up?
What's it say under 2x?
Sorry, it says number of nights.
Okay, thanks.
Sorry, it's right at the bottom of my iPad, so it's hard for me to write. Okay, so then we're doing Jenny. Her equation is going to look like y equals, well, she does 3 pages every night, so that's 3x, and then she already has 6 pages done. All right, well, normally they didn't put a grid on here for us, but what they would want us to do would be to graph both of these and then look for the point where they hit each other. So we'd be looking for the intersection point for these 2 lines. But they didn't give us a grid to graph it on in the note packet. So what I'm going to do is I'm going to do this just by hand, and what you could do is you want to know, if you look at the question, it says, after how many nights will they have read the same amount? So what you got to do is solve for x after you set these equal to each other. So what we're going to do is we're going to set this equal to this. Okay, we want to know after how many nights have Jenny and Ryan read the same amount of pages. So let's set them equal and then solve for x. All right, so we're going to write 2x plus 14 equals 3x plus 6. All right, then we're going to subtract 2x on both sides. The 2x's are going to cancel on the left, and we're going to get 14 equals 3x take away 2x is 1x, or just x. And that's plus 6. Then we're going to subtract 6 on both sides, and we're going to get x equals 8. Again, x represented the number of nights. So this would be after 8 nights, they've read the same amount. So this is 8 nights. But then there's a second part to the question. It also said, let's see, how many pages will that have been? So we want to know after 8 nights, how many pages have they read? So all you got to do is take the 8 and plug it into one of these, doesn't matter which one, plug it into one of these expressions for y. So I'll put it into the first one. So we're going to go y equals 2 times 8 plus 14. And 2 times 8 is 16. 16 plus 14 is 30. So it's y equals 30 pages read. And then notice you could have plugged it into the second equation. You could have plugged it in the one for Jenny here, this one. Okay, it doesn't matter. If you plugged in the 8 for Jenny's equation, so if you take the 8 and you put it in right here for this x, you're still going to get 30 pages, right? Because you're going to get 3 times 8 is 24, and then plus 6 is still going to give you 30 pages. And that'll about wrap it up for this, for section 6-1. Maybe I'll try to rewrite this so you can read that down there. So it's the number of nights. That's not much better. All right. So I'm going to stop the recording here, and then I'll talk to you guys for a second.